So hi everybody, my name is Hernan. I'm going to be talking close to that because there's only one mic, so it gets there. I think that the main objective is it's never a good place to be between you and lunch, but we will have 20 minutes packed of 1 minute per slide, approximately. So we will try to go as deep as possible on whatever we can cover in 20 minutes. So the idea is that I was hired in the company about 2 years ago. You got like another couple of speakers from Salesforce. Salesforce is right now trying to invest a lot in intelligence, in IQ, in trying to use the data in not such an inspiring way like it was presented before on health and things that were going to change people's lives, but we want to change the way businesses have been conducted nowadays. And we want to change the way we are interacting with those businesses and how those businesses are interacting with their customers. And the way we're going to do all of that is just to inject in every interaction that we happen to enjoy in your favorite retailer, your favorite bank, your favorite communications company, your favorite hospital, is going to be powered by Salesforce, and it's going to be powered by the intelligence that is going to be within Salesforce. So part of my role is thinking about the different personas that we have. And this is just one of the personas. The name of product data science is exactly the idea of how do we inject data science in all the products that we build across Salesforce. Salesforce is a multitude of different clouds. We live and breathe out of the log lines. And where are the log lines? Are the application log lines. Every interaction that you're doing with every product in Salesforce across all the different clouds is being collected in real time. We mine that interaction and we try to identify how the product can get better. And that goes from heat maps on what the product is being used from what not being used. That goes from features that are most popular within specific segments in the customer base. Definition of the roadmap of a multi-billion-dollar company that has to identify how to dedicate for the next 3 quarters 200 resources on development on the best ideas that are going to get the highest degree of adoption. The way we do development, the way we do ideation, the way we do even design thinking is now educated by evidence. Nobody just goes into a meeting saying, I have a good idea. It's like, I have a good idea, and the propensity of that idea to hit a success is this much, and the propensity of the customer base to adopt that idea is this much, and this is how we're going to develop. That was something that we were not doing 2 years ago. So this is one of the personas, and the persona is a product manager. So the main, as you can imagine, we have tons of product managers across the different clouds. And it's not an easy task to tell somebody that is coming with a very strong mindset, you know what, this is a great idea, but it may not likely be the best one for what we need to develop right now to unlock the next layer of adoption. We all live and breathe for creating products that are going to be highly used. Having a product that is beautiful and nobody uses, it doesn't stay, right? But the product managers usually feel that everything that they come up with is the best idea ever, and they has to make it, and they has to do it in the sprint, and it has to happen. So we needed to create a way of changing the dialogue in just making sure that that was going to be evidence-driven, that was going to yield a result that we are going to then translate into better user experience, better user adoption, which at the end of the day converts into, the typical common dollar sign, right? But we all need to get to that step in order to deliver value. So there are 3 questions in here. The first one is like, how do we help her identify adoption blockers? If she's a product manager and she's trying to come up with something that is fundamentally new, what are the things that, and Robin is going to be talking about a project that we built that's called OurDNA, that we're borrowing from life sciences, we're borrowing from everything that you can imagine. Most of Robin reports into me, and we hired 3 people from Galvanize already. We have a very mighty team of 4 people under him, and that is the gist of this conversation. Because I told Robin we would used to work in the past, and I led a team of 270 people. And I said, okay, Robin, it's like you worked with me in the past in the tens of people. Now you're going to work with me with 4 people, but you need to be as productive as what you were. So we need to reinvent how we were operating, and this is what we're going to learn today. The second topic, and I just want to hit a little bit of different use cases, is how do we help her identify and build the next best product, or the next best in product. This is all about roadmap management. Imagine that now you are in a room with 200 PMs fighting to get that idea into the sprint, right? And you need to say, I need to create a force ranking mechanism that is going to make sense, that is going to be more of an organic graph, that will have dependencies. So the dependencies will be effort, the dependencies will be likelihood of that feature to be adopted by end users. The dependencies are going to be things like layers of monthly active users. A metric that we live and breathe by is how active the community is on a monthly basis. And well, if I develop his idea versus her idea, we would have more likelihood to unlock 10 million more monthly active users in that particular app. Do you want that, or do you want just more surface content? So that is a dialogue that didn't exist in the past. And finally, what is the right mix of product to build? And here we're borrowing from basic old retailer, right? Math. And this is market basket. Is everything that we learned through many years and identifying what is the best basket of features that, according to clustering and classification and other type of problems that we are solving, we create digital personas that will equip the tool in recommending what are the features that have to surface through UI so you can use them. Most of the things are things that you're going to be seeing live at Dreamforce. So many of the things that we're going to be sharing are, of course, able to be shared right now, but you will see them live in product. And this is how AI is going to take over how we present user experience. So with that.
All right, thank you, Hernan. I think, I hope what you took away from Hernan's intro is that our team has a lot of hard problems to solve. We have to generate a lot of predictive models to help our product managers do their jobs. The problem is data science talent is hard to find. It's a cliche that the data scientist is the unicorn. The reality is that it really is difficult to find people with that really specialized mix of skills. On top of that, when you find those people, they have a lot of competing offers from a lot of exciting companies. We think Salesforce is one of the best to work for, but they have a lot of great options. So what do you do when you're in a resource-constrained situation? What you do is you try to find tools to increase your productivity. And that's exactly what we did to try to make our small team more productive. Now, what does productivity mean in the context of data science and building predictive models? What it means is starting out, we think of it sort of like a funnel. You start out with a large number of data sets and sort of hazy ideas for models you can build. And you try to funnel that down into the few sort of value-driving or money-making ideas that you can actually deploy as models. To do that, you go through three phases. You prep data. You do experimentation. In this sense, we don't only mean, say, statistical testing. We mean any exploration of an idea space, trying out different types of models, trying out different parameters in those models. And finally, if you find a great idea and it works, you deploy something into production. So in a reliable way, you can get those scores or the outputs of those models, right? And when you deploy something, you also need to monitor it to understand if it's working. So what we did is through a combination of procurement and in-house building, we built tools to help us be more productive in each one of these phases. In the first phase, data prep, we found a tool that I'll do a double click on that actually helps us to make our data sets easier to understand and find and document. In the next phase of experimentation, we actually built one tool and procured another one. We built one tool that helps us with large-scale feature engineering to give our data scientists sort of a head start on understanding which data points are useful for the things we want to predict. And we also procured a tool that we think of as a continuous experimentation system that helps to try a lot of ideas in parallel, and I'll double click later on what that is. And finally, in the deployment phase, we found that we were spending a lot of time just trying to monitor lots of models. So we built a tool in-house that helps us to manage that process by exception, which is a time-tested way from the days of industrialization to scale and effort. So let's first take a closer look at the data prep phase. So in order to have a very efficient data prep phase of building predictive models, you need your data to be what we call durable. It has to be easy to find your data sets, has to be easy to understand the content of those data sets and the variables from a business perspective. You have to be able to easily recreate any data sets that you derive in that process. If anyone's ever lost a team member who didn't document their work well, you know it sucks to go recreate a data set. It takes a lot of time. Your data needs to be accurate. Also, a source of thrashing in a predictive modeling process if you find out that there's actually an error in your data. Also, you need all the stakeholders to participate in documenting that data set. You need the business folks, IT, the data scientists themselves. They all have to be a part of documenting that data set. And finally, you have to understand those sources of data. So a lot of time is wasted whenever you have, when your data sets are not durable. If it's hard to find data, you can spend weeks just setting up meetings to try to find data sets. You can also spend weeks with business folks trying to understand what those weird camel case column names really mean from a business perspective. You can spend a couple of days trying to understand if the data is correct. Best case, if it's not, you actually find out and you go back to the beginning and sort of thrash and lose time. Worst case, you don't discover it until much later and it's actually causing problems from a business perspective. Still takes more time, and finally you have to write the scripts. So we found a tool called Alation that helps us shrink that week's worth of time spent on the data prep process into a matter of hours. And what Alation is it's a data cataloging tool, but it does it in an automated way. So whereas traditionally IT is tasked with documenting your data sources, your data sphere, this tool does it automatically. The great thing about that is generally it's a very time-consuming process to do this. What it means is it never gets done. In most data shops, you just don't have well-documented data. You have some tribal knowledge at best, a few folks that you constantly have to reference to understand your data sets. So what happens is you plug your data sets into Alation. In our case, we have a Hadoop cluster and an Oracle relational database. And Alation crawls all those data sets, and it catalogs the relationships between all the tables, the columns. It does some NLP to actually give human readable names to the columns. It also does rectification from a semantic perspective. So it sees columns that it thinks are similar, and it actually tells you that they're the same thing. On top of that, there's also a social layer where you can write articles. The folks who know the data best, the end users, can write articles and have conversations around the data. So for example, if someone finds a column that they think is incorrect, they can start a conversation with the person who is responsible for populating that and resolve that issue. And anyone who comes down the line can benefit from that because they can see the conversation. So the net is the main benefits and speed-ups to data science that this tool gives: faster onboarding, you have an entire history of your data, well-documented data environment. You can ensure your data is correct, less thrashing, and finally you have alignment on semantics so you can be sure that you're using the correct data.
So at this point in time, the most important part that we wanted to cover is that remember that slide that it has like days or weeks into hours. My main problem is that now we are like close to 30 people, right? And all those people were being onboarded really fast, and I literally had the experience of testing having a team with a tool or a technology like this and without. And I hired somebody that started on Monday, and by Thursday, with a tool like this, she was doing her own analysis. She was essentially doing data science in the more canonical way that we define data sciences, which is creating the model. But all the data syndication, data annotations, the way to search for repositories, the way to identify variables, the way to connect with people within the team that was at that point in time already 20 people, it was all done through the social layer. And it's definitely a tool that I will consider. That we all know that 80 to 70, depending on the field, % of the time is spent on just data wrangling. So this tool actually helped us a lot.
Okay, in the roughly minute I have left, I'll explain to you this particular tool that we use for feature selection that we built in-house. So we found that we spent a lot of time, we're a product team, so we have a lot of utilization metrics about which features folks are using, a lot of data points. So we found we spent a lot of time doing feature engineering, just looking through those metrics to find what was indicative of things we cared about. So we built this system called OrgDNA. Our Salesforce deployments are called orgs. So this helps us to find the drivers of behavior within those orgs. And the way it works is you can think of it as sort of an automated statistician. It slices and dices the data sets looking for different subpopulations, and it uses as a baseline the global population with all the rows. And for example, a target metric you might care about is revenue. It takes as baseline the revenue for the general population. As it explores subpopulations, it looks for subpopulations where the value of that target metric is very different from the baseline. It does this, you can think of it as F-tests between the baseline and the different subpopulations. And when you find an interesting population, the dimensions that describe that population are then your interesting features, including interactions, which is really powerful, and this saves us a lot of time doing feature engineering. Another tool that we use in-house is a tool called Domino. We think of it as a continuous experimentation system with an allusion to continuous integration in DevOps. So whereas continuous integration in DevOps helps you to find bugs really quickly and to produce correct code, this helps us to experiment very quickly. So the way it works is it consists of two main components. One is a very special version control system that's optimized for data science, in that it allows you to version code as well as the data that the code is operating on, as well as any social commentary and conversations around that data, and the results of any experimentation all together in one artifact. It also has a Dockerized back-end system that you can fork different versions of this code and execute them. This paradigm of doing Dockerized data science is very powerful, and I'll do a double click and explain exactly why. So the reason versioning your data sets, your code, as well as your results all together is so powerful is it allows you to try lots of different things in parallel, because you can make apples to apples comparisons. This is the heart of any kind of science, not just data science. The ability to know that if you make a change and you get an improvement, say in the AUC of your model score, that it's actually based in the change you made and not some, not because you used a different version of a solver in your logistic regression model, for example. So if you couple the apples to apples comparison with the power of Docker, where not only is your not only because you versioned everything are you assured that you're using the same data and that sort of stuff, with the container, you also assured that you're actually using the same operating system, the same configs, the same R packages, everything is exactly the same, right? So this means that you can use the power of Docker and the power of distributed system to try lots and lots of different variations massively in parallel and much more quickly find valuable solutions to your problems. So one question we get a lot is why not just use GitHub? Well, GitHub is not really meant for data science. It means you can't version large data sets. It means that it doesn't have support for notebooks like Jupyter, which are common tools that we use in data science. So the artifacts are really not around experiments, and that just doesn't work out well for data science. So in summary, the benefits we get from this tool are reproducibility, the ability to massively try a lot of ideas in parallel, and the the ability to bring lots and lots of brains together with the social aspect to solve a problem. So the last problem we faced was that we were spending a lot of time monitoring our deployments. We're only 4 data scientists, and as we deployed more and more models, we found that we just spent too much time monitoring those deployments to make sure the models weren't drifting or the underlying domain wasn't changing. So we built a tool to help with that process. So the tool takes in as parameters the type of model, a forecasting model, for example, the type of metrics you want to measure that model against. In this case, it might be something like an RMSE, and also the cadence with which you want updates about the performance of that model. And what it outputs for us is things like alerts on model drift. It tells us if underlying distributions of input variables are changing, which is usually a sign that your domain has shifted and it's time to retrain a model. And it gives us alerts of all these things so we can really manage our pipelines by exception. So the benefit of that is that with just a few lines of code, a data scientist can monitor the models they deploy and spend a lot less time both writing the code to do this and a lot less time sort of scrutinizing individual models. And so with that, thank you very much for your attention.
We are at time. The deck will be published, has a lot more information. We're going to stay for a couple of hours for any questions that you may have. And I don't know if we have time for questions.
Is this open source?
This is not open source. This is not open source, but the vision is that we're going to be investing a lot on open source, particularly starting sometime early next year. But right now, as you can see, this is an ensemble of processes and technology that is using a lot of open source packages and things that we collaborate with. But this is not open source.
Well, thank you very much.